Going to start off with Cambridge O-Level Physics, alternate to practical, which is paper 4, and its variant is 5054/42. And we are going to solve October-November 2022 paper. So let's off with the question number 1. And the question number 1 states that a student measures the resistance R of a lamp for a different values of the potential difference V across it. The student connects the circuit shown in figure 1.1, and the student closes the switch, connects the crocodile clips at the length L equals to 10 centimeter of the resistance wire, records the potential difference V across the lamp, records the current I in the lamp, open the switches, shows the reading. Okay, so the first question is this, that you need to find out the values of the voltmeter and what is the value in the ammeter. So if you do these calculations, so this is going to be like there are 10 divisions. You can count them: 3, 4, 5, 6, 7, 8, 9, 10 divisions. So this means 0.5 volts equals to 10 divisions. And now you see this thing, that 1, 2, 3, 4. So you need to find out 4 divisions equals to what voltage is this. So you cross multiply this thing. So 0.5 times 4 divided by 10, you'll get the value of this. So okay, so when you do the calculations, you will end up with 0.2 volts. So the reading on this voltmeter is going to be 0.2 volts, whereas if you count these lines, so it's going to be 9. So you will end up with the result 0.09. So we have to complete the table as per the question is talking, saying staying 0.2 volts will be here and 0.09 ampere will be here. So resistance, as per the Ohm's law, you know that thing V is equals to IR, voltage divided by current is equals to the resistance. So if you do the calculation again, 0.2 divided by 0.09, so you will end up with 2.2 ohms. That will be the resistance of this thing. Okay, now we have to complete this value as well. Okay, so again we're using the Ohm's law, which is V equals to IR. So voltage divided by resistance is equals to I. So this is again voltage is this value 2.5 divided by 11.9, and you will end up with 0.2100, and we will have this value is over here. The student repeats the procedure with a different length L of the resistance wire. The student results are shown in table 1.1. Complete the top row by calculating the resistance of the lamp when L is equal to 10 centimeter. We have already done this question. Then complete the top row of table 1.1, calculating the resistance R of the lamp when L is equal to this and the resistance is equal to this. The student forgets to write the current value of L equals to 100. Calculate the current and write the value of the value in table 1. So we all have already done this values, which is around 0.21 amps. This is again I have done the calculations, you guys can see that thing. The student examines 1.1 table 1.1 and states that the resistance R of the lamp is directly proportional to length. Share if you agree the student's statement. Justify your answer by using the table from table 1.1. So if you see the data, so you can write it down that the resistance of the lamp is not directly proportional to length. So no, I do not agree with this thing. And then the justification is this, that you can write it down that the ratio to resistance and length are not constant. So if you divide those things, so you won't be able to get the one value. So this means that the resistance is inversely proportional to length. Okay, let's move to the next question, and it states that again you have to plot the graph values Okay, on the grid provided that this plot graph are on the y-axis. So on the y-axis you have the resistance. First of all, you have to label the axis, and on the x-axis you have the voltage, and then we have to see the data, and then we have to plot those values. So if you talk about the resistance, so resistance will be around like 2 4 and my bad 2 4 6 8 10, and this is going to be 12. Yeah. And over here in the case of voltage, so I will be doing 0 0.5, 1 volts, 1.5 volts, and 2 volts, and this is going to be 2.5 volts. So if you plot these values, so you can, I hope you know how to plot these values. So you will be ending up with a graph like this. So start the axis on the origin, so the plot will be like this, somewhat like this. Okay, so I'm not plotting those values. I hope you guys are clear with that. So I just drew a graph sample that you are going to get from this question. Draw a smooth curve of the best straight line. So again, you have to remember this thing. Use a clutch pencil rather than a lead pencil, because thing is this, over there the line is gets thicker, and you won't be able to get a proper value over there. So try to do this thing, and don't forget to label your x-axis and y-axis. Using your graph, describe how the resistance of the lamp changes as the potential difference V across is changes. So this means as the potential difference is increased, so resistance is also going to be increased. So which means this is a non-linear curve, a non-linear graph, because it's a curve graph, non-linear graph. And you can also write it down that the rate of increase in resistance is decreasing. So it's up to you guys that what you are going to do, write it down, because it carries 2 marks, so you need to write 2 justification for this question. Another student makes changes to the circuit shown in figure 1.1. She uses variable resistor to vary the current and the potential difference instead of resistance wire and the crocodile clips. Complete the circuit diagram figure 1.4 to show how this is going to be done. So you simply add a variable resistor over here and then connect this point to this. So this is going to be done. This is moving to the next question. A student determines the acceleration of free fall by timing the oscillation of a pendulum. The pendulum is shown over here. Okay, on the figure 2.1, measure the length. Again, this is the measured thing. So you have to put a scale over here, and then you have to measure this length. So it's going to be around 3.5 centimeter. Okay, 3.5 centimeter. Figure 2.1 is drawn 1/8 of actual size. Length L is the actual length of the pendulum. Calculate length. So how you are going to do is, like, the actual length, if I take it 1, uh, okay, I'll do this thing. If the figure is 1, the actual length will be what is going to be 8. And if I talk about like the actual length of this pendulum is 3.5, so it's going to be x. So now again we will do what, cross multiplication. But if I do the cross multiplication, this means that both values vary with this. So I am going to do this. Okay, so if I do this cross multiplication thing, so I will be ending up with x equals to 28. So the length will be 28 centimeters. So this is an easy question again. Remember this thing, the unitary method is going to be, sometimes it is going to be used in physics, in chemistry, and in mathematics. No matter there is a formula for that, but it is very important that most of the question they are going to be solved with this procedure. So you might be knowing this thing. Okay, moving to the next question. The student gives the bob a small displacement and releases it so that it swings back and forth. Figure 2.1 figure, sorry, 2.2 shows one complete oscillation of a pendulum. So this is the complete oscillation of the pendulum, which is been drawn over here. And the student measures the time t for 20 complete oscillation. The time t is shown on the stopwatch, figure 2.3. Write down the time t. So what is the time over here? So you have already, it's given in seconds, so you have to write it down, 21.21 seconds. The student measures the time t for the 20 oscillation twice more. These times are shown like this. Find the average t average for the 20 oscillation of the pendulum. So in this, there is one calculation missing, which is going to be 21.21, and then you have to find out the average. So it's going to be 21.21 plus 21.30 plus 21.28 divided by 3. So it's going to be 21.26, which is going to be the answer over here. The time period, the period time is the time for one complete oscillation of the pendulum, and calculate t. So t is equals to 21.26 divided by 20, and this is going to be the time period for one complete oscillation, and it's going to be 1.06 seconds. The unit are already mentioned, so no need to mention those things. Calculate the value of g, the acceleration of free fall. Use the equation this and give your answer to three significant figures. So it's going to be 11.1 divided by t square. T square means like the value is given over here, so I'm going to be using this value. So it's going to be 9.82 meter per second square. So again, this value is going to come over here. Now, to find out the period t of a pendulum, the student first measures the average time for the 20 oscillations. Suggests why the student did not choose to measure the average time for the 2 oscillations. So obviously the reaction time error, because if he does, so there will be human reaction, human error, because the humans are not quick enough to find out this for 2 oscillation. Reaction time error there may be, or you can say that the time for 2 oscillation might be time for 2 oscillation will be so small. So you see this thing that if you find out the time period of pendulum for 2 oscillation, that will be again so small, and there will be chances of reaction, human reaction errors. And for 200 oscillations, so obviously there will be air resistance, there will be drag forces acting on the pendulum, which is going to stop the pendulum. So that's why we are not going to take 200 oscillation. Stop air resistance is, okay, hold on, let me clear this. Air resistance, or you can say this friction, is acting on it, I mean the pendulum, and it might stop till that time. So that time is not required or useful for us. A student uses a ray box to investigate the refraction of a ray of red light as it passes through a semi-circular glass block. He sets up separators on a sheet of paper as shown in figure 3.1. This is the sheet of paper. There is a ray box. There is a red filled normal semi-circular glass block. It's up to you. Either you guys consider semi-circular or semi-circular glass block. So what we have to do is, like, let me go ahead. The ray is incident at M, the midpoint at flat surface of the semicircular glass block. Measure the angle of incident of the, that we have to measure the angle of incident. So obviously you have to remember this thing, that these are the incident ray. This line is incident and this is normal. The angle between incident ray and this is like this, is called as incident angle. So over here again you see this is measure. So if you measure that thing, so you will end up with 34 degrees. So this is going to be your answer for this part. Okay, so then there were no units, so you guys can add it up over there. Okay, moving to the next question. The angle of refraction at M is 22 degrees. On figure 3.1, draw the refracted ray inside the glass block. So, so this is what you have to do is like you have to make a refracted ray and make an angle of 22 degrees. So you have to draw the arrow as well to show that the ray is traveling, the refracted ray is traveling in this point. Then you have to draw the point N over here. This is what is expected in next part. Okay, so we have done with this. Draw the refracted ray of this. We have done with the angle. Label the letter N, the point where the ray is refracted, and leave the glass block. The ray emerges from the glass block at N without further deviation. We have already done. Draw the path of refracted ray after it leaves. We have done this. Describe how the student uses optics pin to mark the path of the ray accurately. So you have to place the pins on the ray. This is basically the light rays, okay, and join them. Simple as that. So basically what you have to do is if you are pointing your laser light to this thing, semicircular block, so this is your normal again, so it's going to like refract like this. So you just have to put your pins over here and then join them. So these are your pins, okay, these are your pins. So this is how you do this question. Moving to the next question, the last question, and it states that the student uses thermometer to measure the temperature of hot water as it cools down to a beaker. Explain why he takes the following steps to ensure that the values are accurate. He makes sure the thermometer bulb does not touch the sides or the base of the beaker. So obviously the sides or the base, they have different temperature, side and the bases have different temperature. So that's why he is not letting the thermometer to touch that base or the walls. It stirs the water each time before taking the reading. So it's basically ensuring that the temperature is uniform, ensuring the temperature is uniform. It takes the temperature reading by viewing the scale on the thermometer at eye level perpendicular to the scale. So why he is doing this? Because he wants to avoid the parallax error. Thank you very much.